Hi everyone, and welcome to the next part of the e-learning where we will be making use of the formula to find the area of a sector in these few examples. So let's take a look at the first example. Find the area of the shaded sector, which is right over here. We want to find the area of this pizza slice over here. Okay, so just to quickly recap, the formula for the area of a sector is x degrees, okay, where the angle represents the angle at the center divided by 360 degrees times pi r square. So simply plugging the numbers, we have area of shaded sector equals to 60 over 360 times pi 1 square. Alright, substitute the numbers in now because this is an exact number. Once again, actually when you key this in, you'll notice that the number goes on and on. So in this case, even though we make use of 3.142, you still have to change this to 3SF to get 0.524 meters square. Okay. What happens if now I give you the area of the sector and I want you to find the size of the corresponding angle? Now this is not difficult. Okay, simply apply the formula x over 360 times pi r square. R is 2.5 in this square equals to 15. Okay, slowly plug it in and then you slowly manipulate. Okay, substitute in and do the necessary manipulation. Substitute pi to be 3.142. Okay, so I divide this, to make this the subject, I divide 3.142 and 2.5 square over, and to find x, I multiply 360 over, and this will give me x equals to 274.9840 degrees. Now let's check if our answers make sense. We know that this angle definitely has to be more than 180 degrees. So yes, it's quite reasonable for my angle to be such. Change all angles to 1 decimal places. Okay, all angles are to be changed to 1 decimal place, so you will get 275.0 degrees to 1 decimal place. Alright, so let's take a look at our third example. Okay, the figure shows a quadrant. Now, the moment you see the word quadrant, please know that quadrant means it is part of a circle. Okay, with center O and radius 22 centimeters. Take note, these two are the radiuses of the quadrant or the circle. Find the area of the triangle and the area of the shaded region. So to find the area of the quadrant, to find the area of the triangle, actually it's not that hard. Okay, but to find the area of the shaded region, let's try doing that. Okay, you notice that all I have to do is to find the area of the quadrant minus the area of the triangle. Okay, so to find the area of the quadrant, I will make use of the formula. Okay, 90 over 360 times pi r square, which will give me 380.132 centimeters squared. Don't round this off first because we'll be using this value later. To find the area of the triangle, simply take half times base times height. The base and the height are 22 each, so 0.5 times 22 times 22, which will give me 242 centimeters squared. And hence, to find the shaded region, just take a difference of these two values and change it to 3SF to get 138 centimeters square. Alright, let's move on to this example. I don't think this example is very unfamiliar to you guys, okay, but so let's go through it. Okay, so in this diagram, square ABCD has sides of 5 centimeters each. The shaded region is enclosed by arcs. Okay, take note, the arc is this curved line over here. Okay, with centers at A and C respectively. Okay, so find the area of the shaded region. Now to do that, what I'm going to do is, first I need to know the angle. This angle over here is 90 degrees. Okay, since this angle over here is 90 degrees and this is an arc, what does this tell you about this shape over here? It tells me, and if I have to divide it, okay, first I divide it so you get two triangles. What does it tell me about this curved part over here? It actually is a quadrant. Can you see this is a quadrant? So actually you can tell, all you need to do to find the area of the shaded region is I just need to find one of them here, use the area of the quadrant minus the area of the triangle. Okay, so let's try doing that. So to find the area of the quadrant ABD, all I have to do is just take 90 over 360 times pi r squared. Notice this is the radius. This is not the diameter, it's the radius, radius of 5. Okay, times pi 5 square. Okay, substitute 22 over 7. Now, like I said, if they give you the value of pi, you use it. Okay, you will get 19.6428 centimeters square. Then, to find the area of this triangle over here, can you see? I want to find the area of this triangle over here, because if I take this minus the area of the triangle, I will get this area over here. So area of triangle ABD is half times 5 times 5, which will give me 12.5 centimeters square. And to find, what I'm going to do now is I'm going to label this region 1. So area of shaded region 1 is just 19.6428 minus 12.5, which will give me 7.1428. Now, don't round this off yet because you notice that these two are actually the same shapes. So what you can do to find the total shaded area, what you need to do is to multiply it by 2, and you will get 14.3 centimeters square to 3 SF. Alright? And in our last example, okay, this last example is slightly a little bit more challenging, but it is not difficult as long as you know which lines to draw. Alright, so let's take a look at this example. The figure shows two circular discs of radius 11 centimeters and 7 centimeters touching each other at R and lying on a straight line MPQN. Okay, so you can tell that obviously this shape here is actually a trapezium. Alright, and so what they want us to do is actually to find this particular angle over here. So how do we go about doing that? Now, take a look at the things that we have been given. We are only given these two dimensions. Okay, we are only given these two dimensions and we are only given lengths. So we cannot just use Pythagoras theorem over here because Pythagoras theorem doesn't help us to find angles at all. So your only resort actually is to use Tuakaso. So how do we go about doing that? We need to first identify where on earth is our right angled triangle. Okay, and this is where our right angled triangle is. So now I want you to take a few moments to try and figure out how would you use the lengths given to help you find this angle over here. I'll give you a hint. Length AR is 11 centimeters because it is the radius of a circle. Length BR is 7 centimeters because it is also the radius of the smaller circle. So how would you go about doing that? Think about it. Okay, pause the video for a while and try it yourself. Alright, I hope that you have figured it out, okay, and you could see that, okay, these two lengths here actually add up to 18 centimeters. And there's this other length that we can find, which is actually here. Do you notice this short length over here? All I have to do is just take 11 minus 7, and this will give me 4 centimeters. Can you see I have my length here, I have my length here. This is my angle of interest. So this makes this the adjacent. This makes this the hypotenuse. I have my adjacent, I have the hypotenuse. So the trigonometric ratio I can use here, Tuakaso, K, A, and H. Okay, I can use the cosine trigonometric ratio to get this. Okay, so cosine angle PAB is just A, which is 4 over H, 11 plus 7. So this angle PAB is just, I bring the cosine over cosine inverse 4 over 11 plus 7. Evaluate this to be 77.1604 degrees. Changes to 1 decimal place and I will get 77.2 degrees to 1 decimal place. So in the next portion, okay, I'm asked to find the length of PQ. So how do I go about doing this? Now, I know that this length PQ over here is the same as OB. I have this length over here, which I know is 11 plus 7, which is 18 centimeters. I have this length over here, and this is definitely a right angled triangle. So how? Okay, yes, I can use Pythagoras theorem. So using Pythagoras theorem, because PQ is equals to OB, OB is simply just 11 plus 7, which is 18 square minus 4 square, which gives us 17.5499 centimeters. Change this to 3SF and I will get 17.5 centimeters. Okay, and in this last part, find the area of the shaded region. Now you notice that to find the area of this shaded region, what I can do, I don't require you to divide anything up, okay? Look at the big picture. I have a trapezium here. I have two sectors over here, two pizza slices over here. I can already find the area of this pizza slice because earlier I have already found this angle. The question is, can I find the area of this pizza slice over here? Actually, yes, you can, because you can make use of the property and you can make use of the fact that these two lines are actually parallel. So just to draw you back to something that we have learned before in Sec 2, when two lines are parallel, okay, and these two angles here are actually called interior angles, and one of the properties of the interior angles is that they add up to 180 degrees. So you see, I've already found this angle. Can I find this angle? Do you notice there are two interior angles over here? Yes, I can, simply by taking 180 degrees minus this angle. So angle RBQ is equals to 180 minus 77.1604 degrees. Interior, please don't forget to write the reason. Interior angles AP parallel to BQ, and this will give me 102.8396 degrees. Now, I can find the sector area of ARP as I've said earlier using the formula angle over 360 times pi r square. This will give me this value. I can find the area of this sector over here, 102.8396 degree over 360 degrees times pi r square, which is 7. Pi 7 square. This will give me 43.9747 centimeters square. Alright, okay, this is very long. We already found these two areas. So how do we find the area of the trapezium? So to find the area of the trapezium, all I have to do is just apply the formula half times sum of parallel lines 7 plus 11 times height, which is 17.549 centimeters. This will give me 157.941 centimeters square. So to find the area of this shaded region, I just take this value minus the two sector areas, and I will get 32.5 centimeters square corrected to 3 significant figures. Alright, so example 5 is actually one of the longer examples, the more complex examples involving almost everything you notice that you have learned from geometry, okay, including angles and all that. Please try and get used to it, okay. In the homework assignments that are given, okay, these are due first lesson of term 3 week 1, okay. I know that question 2 and 4 are slightly faded in terms of the shaded area. So for the homework assignment 2 on your last page, can you please make sure you shade this area up so that you know how to do the questions. Alright, please remember to practice, and happy holidays. Alright, see you when school reopens. Thank you.